Hey guys, this might not look like a GED question of the day, but I promise you it is. I just borrowed this from another site. So it's GED question of the day time, and I've got a Super Mario math challenge going on here. So let's read about this before we take a look. Whoa, forgot to bust out my pen, which I do about half the time. So we see this language here. It says the area model below represents the value 182. Find the value of each icon. So I know something about the word area. Area is a geometry concept that comes up on the GED. And the idea of area is the number of boxes or the number of squares, that's a better way to put it, it would take to cover a shape. The number of squares it would take to cover a shape. Before I hit my Super Mario challenge, I just want to show you what I mean. So let's take out a different color. For example, if I knew that a particular rectangle was 4 inches wide, 1, 2, 3, 4, I could kind of like divide it down those lines, 1 inch, 2 inch, 3 inch. So it's 4 inches wide. You can see I've divided it into 4 columns. And it's 3 inches tall. 3, and then be 1, 2, 3. I could divide it into inch segments going this way. And I would see that I would take 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 little squares to cover this rectangle. It's a 3 by 4. So its area is 12 square inches. Now, you can hopefully see that this is a picture of multiplication. I've got 3 rows. Each row has 4 boxes, so I have 3 groups of 4. I have 3 times 4. So area is one way to visualize what we're doing when we multiply. So with that knowledge, let's hit up our problem. Okay, so one thing I notice here is that this entire box is labeled 100, meaning it's got an area of 100. Remember, 100 little squares that it would take. And I can see that coming across on this end, I know that it's 10 this way. And so a question that I could ask myself is 10 times what equals 100? 10 times what equals 100? Well, hopefully you guys know that 10 times 10 equals 100. And so I see right away that I could substitute 10 for my flower. So 10 for my flower. Okay, now let's take a look at Mr. Mario. Oh, I don't like Mario. There's too many unknowns. Yeah, I'll just tell you why I don't like Mario. Because, just because I'm a math teacher doesn't mean I don't go the wrong way sometimes. I looked at Mario and I wanted to start with him, but I realized there were too many things I didn't know. Not only do I not know Mario, I don't know the toad above him. I only know one thing, and there's 2 unknowns. What am I going to do? That's not a good place to start. Let's go find a place where I know more numbers. Ooh, I don't have a place where I know more numbers. Oh, guys, I am being kind of dumb. I forgot I had this number. The area model below represents the value 182. Huh. Yeah, I should have worked this out beforehand, but that's okay. You guys can see my process. So I got 182 total squares, and now I know that I have 100 right here. I'll take that 100 out. That's that piece. So if I take that out, I'd have 82 left. And I see I have that 12 there. So if I take 12 out, I'd have, let's see, 70 left. So between these two pieces I don't know, those 2 guys are going to have to total up to 70. Tricky. Okay, I'm going to go with some possibilities based on this 12. I think that's what I'll do next. Because I have all these places where I don't know. Like if I look at the 12, I know this number, but I don't know the toad, and I don't know the turtle. If I look at this one, I don't know the star, I don't know the turtle. So, I don't have a lot to go on right now. So what I'm going to do is start making some good guesses. I want to think of all the ways to multiply to 12. You help me out. So I could multiply Oh my goodness, let's think. Well, 1 times 12. So it could be that one of these numbers is a 1 and one of these numbers is a 12. I could multiply 2 times 6. So it could be that one of these numbers is a 2 and one of these numbers is a 6. I could multiply 3 times 4. So it could be that my little toady is a 3 and my little turtle shell is a 4, or vice versa. Okay, so those are my possible numbers that I'm working with. But I know I also have to multiply to 182. Oh my goodness. And when I say I need to multiply to 182, yes, this box here needed to multiply to 12. This times this needed to multiply to 12. But we know that the entire thing is 182, which means this times this need to be able to multiply to 182. Okay, so let's see. Ways to multiply to 182. Can I divide 182 by 11? 11 and 72, no. Can I divide? So I'm doing division in my head, guys. If you guys aren't good at doing division in your head, it's going to make this problem especially difficult. But I was just really quickly saying 11 went into 182 once, but then the remainder that I would get, 72, is not going to be divided perfectly by 11. So 11's not going to work. Let's see. 12 is 182 divisible by 12. 12 and 62, nope. Oh my gosh. How about 13? I don't know my 13 times tables one. 52. Let's see. 13, 26, 39. What am I doing? I'm counting by 13s. 13, 26, 39, 52, baby. Oh, what? There are 4 13s and 52. I just figured something out. I just figured out that 13 times 14 is equal to 182. Here's why this is exciting. Here's why this is exciting. Let me do some erasing. Okay, 13 times 14 has to equal 182. And so I already knew that from here to here was 10. So if I wanted this to be 13 all the way across, it would either have to be, it would be a 3 here, or if I wanted this to be 14 all the way across, this would have to be a 4. So my only possibilities for the little mushroom guy are 3 or 4. And then this is super exciting because this also would have to be 3 or 4. So that this total length, since this piece is 10, would also be 13 or 14. So again, what am I trying to do? I'm trying to get a total of 13 or 14 here because I just figured out that 13 times 14 is 182. 13 or 14 there. Now this is really, really good news. That was why I was so excited when I saw it, because I know that that is going to check for this number. 3 times 4 is the same as 12. So if one of these is a 3 and one of these is a 4, I'm going to get 12. So now all I have to figure out now is which one is which. So let's use the star and Mario to see if we can figure that out. The star and Mario to see if we can figure that out. Does it matter? Does it matter? So let's see. It could be that this was a 3. If this was a 3, then Mario would be 30. And then I could cross this guy off and he would be... Why am I crossing that off? Oh, sorry. I just decided this one was a 3. So if this one is a 3, this one has to be a 4. I love it when I don't let you guys follow along with my logic. So, okay, I have a 3 there and I have a 4 there. I'm just checking to see if everything works. So 10 times 10 would be 100. 3 times 10 would be 30. 10 times 4 would be 40. And 3 times 4 would be 12. And do those all add up to 182? Let's take a look. I'm going to need some space. So I just guessed. I just made some really good guesses based on some logic here. And again, sometimes life is not perfect. But this, I never promised you a rose garden, y'all. Never promised you easy math. Let's check if our guesses work. Does my 100 rectangle plus my 30 rectangle plus my 40 rectangle plus my 12 rectangle add to 182? 3, 7, 8, 182. Oh, what's up? Wonderful. We're brilliant. We found an answer that works. Does this mean this is the only answer that works? No. I'm actually kind of interested in trying 4 and 3 in the other opposite way and see if it'll still work. It might very well. In fact, I think it would. But I like it better this way because it makes more sense for this one to be worth 30, the smaller one, and this one to be worth 40, the larger one. But just to let you know, when you're doing your GED, there's no guarantee that the picture is anything like the real life, so don't assume. But anyway, my number's checked, so we're going to call it good. So my little mushroom then is worth 3. My little flower we had decided was 10. Mario was 30. The little turtle shell was 4, we decided, and the star was 40. I'd love to hear if you did it a different way. Again, as long as your logic carries through and all the math checks, you have a good answer too. But this is gorgeous. This is actually really good prep, what we just did for the first 5 problems of the GED, because they can often have what are known as divisibility problems. Divisibility is a big group of math. It includes factoring, prime factorization, greatest common factors, reducing fractions, least common multiples. If you've heard of any of those things, you were actually working on divisibility. And this problem, whether we realized it or not, really was exercising those divisibility skills. So great. Good news though, yay. No Super Mario math challenges on the GED. All right, you're probably mad at me after this video if you even stuck it out. But if you have any comments, go ahead, leave them. We can fight about math. We could talk about a different way you went or a different way you thought about it. Or you could just ask me what the heck I was talking about, and I'll be happy to answer you. Till next time.